7.3 Euler's number. The man who gave us many things in mathematics gave us a special number E, which is a natural phenomenon number. He gave us a lot of stuff on logarithms, calculus, although it wasn't quite calculus, but some of the concepts in calculus came from him. He gave us a lot of stuff in math. Anyways, this is his number, E. It's Euler's number. And the big thing from this section is just playing with E. That's all it is. When I look at number 2, I think about the property AB to the x. It's A to the x, B to the x. So I think 2 to the negative 4th, E to the negative 2 times a negative 4. This becomes 2 to the negative 4th, E to the negative 8th. And I have to rewrite this. So I also think about the rule that talks about x to the negative n being 1 over x to the n. I just think about rules. That's 1 over 2 to the 4th, e to the 8th, and then I figure out what 2 to the 4th is by doing 2 times 2 times 2 times 2, and I get 1 over 16e to the 8th power. All right, number 4. When I glance at number 4, what I think about is I think about x to the a times x to the b, which is x to the a plus b. So that's really all I do. The exponential space becomes x plus 2x minus 3, and that becomes e to the 3x minus 3. Kind of funky, isn't it? This, by the way, I'm not asking you to do this. This could be written as e to the 3x over e cubed, because you also have the rule about x to the a over x to the b being x to the a minus b. So keep that in mind, okay? I have seen this on standardized tests before. This is usually where we stop. There's a reason we usually stop here. That's related. This is useless in calculus. This is useful. So we almost always stop here. Number 7, what do we got here? A cubic root? Cubic roots are easy. The cubic root of 8 is a 2. What on earth is the cubic root of e to the 9x? Huh? It's actually e to the 3x. Weird, huh? The reason it's e to the 3x is because 9x over 3 is 3x with a remainder equal to 0. Remember that whole dividing? We divide the power by the root. 9 looks kind of funky. That is a square root with an understood 2 of 4 times 27 e to the 13th x over 3 e to the 7th x to the negative 13th. So lots of stuff going on. I'm going to do some simplification here. 3 and 27 makes 9. I'm going to move that 7 up. So I'm going to do subtraction in the exponential space. I'm going to move this up too. Remember, when you jump from the denominator to the numerator, your sign changes and vice versa. So I'm subtracting 7 from 13. I'm adding 3 to 1. That is a 1, believe it or not. 4 times 9 is 36. 13 minus 7 is, what, 6? And that's x to the 4th. And again, I'm taking the square root. The square root of 36 is 6. 2 enters 6 3 times, no remainder. 2 enters 4, 2 times, no remainder. You shouldn't need a video to do 10, 11, 12, or 13, but why not? 5e to the negative 2 over 3. It's just that simple. It says round to the 4th decimal, 10,000th, so 2.5671. The 0, the 8 turns into 1. It's about 2.5671. I honestly doubt that I taught 14 and 15 in class, because you have to use a calculator anyways for these. I mean, you legit have no choice but to use a calculator. None. That being said, this is a left 1. Sorry. Yeah, left 1. And that is a down 3. So left 1, fall 3. This would normally be exponential growth, and normally exponential growth from y'all's perspective would look, I guess, something like that, right? I'm on quick camera here, so is it backwards? I don't know. It would normally look like this. This guy right here, that negative symbol, is going to make it look like this. You have to understand that. I am going to pick on 3 values, and I'm probably going to get them from I'm just going to plug them in and get them, see what they generate. I know that x is -1, something before that's -2, something after that is 0. So take a -2, store it to x. E to the negative parentheses x plus 1 minus 3 is a negative 0.28. It's about negative 0.3. Take a -1, store it to x. -2. That one's always nice. Take a 0, store it to x. Negative 2.63. So the values are actually starting high and ending smaller. Why did I say shift down 3 and didn't do it? This is not supposed to be there, okay? Oops. So -2 is -3/10. -1 is -2, and 0 is getting closer to that asymptote. And it's going to look like this. I said I was going to talk about a table, didn't I? I will in just a second. Your domain is -infinity to infinity. Your range is going to be -3 to infinity. And your horizontal asymptote is right here at y equals -3. It was right there the whole time. All right, so here was the equation. It was e to the negative x plus 1 minus 3. I went to y equals, zoom 6. And see, I was right. I told you that's what it looked like. You can get your pointer over here by hitting second table. There's the -1. Somebody has been pushing some weird buttons on my calculator. Yes, they have. Second table set. Somebody is playing with calculators and they shouldn't. There we go. That's better. So there's all those values I had earlier. And there's some more too. Your calculator actually is lying over here. This is not true. You never get to be -3. The deal is it cannot calculate it. It's rounding is what it's doing. It's not -3, regardless of what your TI-84 says. Oh, this isn't right. Oh, it is right. Yeah, I put some review stuff on this one. Given functions f of x is the root of 3x minus 4 and g of x is 2x squared minus 8, find f of g of x and state the domain. So here's g of x, which means that x is going to become this. Which is going to be the root of 6x squared minus 24. Now I'm thinking about a rule, talks about the square root of anything. Anything must be greater than or equal to 0. 6x squared minus 24 must be greater than or equal to 0. 6x squared is greater than or equal to 24. X squared is greater than or equal to 4. X is greater than or equal to 2, plus or minus. Kind of funky. Which one is it? Or is it both? Well, it's the stuff between. If I make up like a number that's bigger than 2, like a 3, sorry, it's not the stuff between, the stuff on the outside. If I was to plug in a 3, this would become 6 times 9, which is 54 minus 24. This would become root 30, which is doable. So I do agree that x is greater than or equal to 2. Now, if I did the same thing with a -3, it'd still be doable. Or x is less than or equal to -2. There's my domain. Whoops, I'm screwing things up. Curly braces, all values of x such that x is greater than or equal to 2 or x is less than or equal to -2. Kind of funky. 19, find g over f. Literally, g over f is 2x squared minus 8 over the square root of 3x minus 4. That's g over f. That's it. State the domain. Somewhere in your old notes, you'll have this 1 over root a. A is greater than 0. That's it. 3x minus 4 bigger than 0. 3x is bigger than 4. X is greater than 4/3. So all values of x such that x is greater than 4/3, or if you like interval notation, 4/3 to infinity. And we have the ACT stuff, which I will have to do after school because I just ran out of time.